All right. So here's the introduction to our second rolling bowling ball lab. Um, so you should have found your way to Pivot from Canvas. You'll also have noticed maybe in the Canvas assignment there is a link to a Desmos graphing page. You might want to open that in a separate tab. We're going to use both together. So up here, part one, making the model and predictions. We start with a question here. Like in our first bowling ball lab, you will be plotting position versus time for the bowling ball and generating an equation for the motion. Whoops, motion. How will the graph and the equation be similar to those you found in level one? How will they be different? What do you see in the video that makes you think so? Explain that. So first, of course, we need to watch the video. So let's watch the video real quick. So we see the ball rolling to the left. Well, seems a lot like what we did before. Now, second, let's consider what happens when we bring the ruler and the stopwatch into action here. Reset the video, bring the ruler down like I did before, and oh, look at that. We can't line up the 0 mark with the ball. So let's line up the 0 mark with the flag instead of the ball. Let's try to get it right on there, right about there. Beautiful. So now what I can see is the flag is 0, and I'm going to have to take measurements of where the bowling ball itself is. So this might give you some hint as to what might change about our graph. We're going to start with the bowling ball at time 0 being at like 126, and then those distance numbers are going to get smaller as time goes on. You know, um, so to do the activity, first you need to choose a trial. Like in the pendulum lab, we're going to be able to choose up to 19 trials. Use this random number generator here to choose a trial. Oop, it jumped off my page there. Um, so you click on that. It's going to generate a random number for you. You're going to come back here. First thing you might want to do is come down to the question 3. What trial are you using? Type in a number here. And then you're going to load your trial. Now you're going to collect data like you did before. This time, though, we're going to collect data starting with the time at 0. Now, my favorite way to collect data is to use this step through the video button here. You can go frame by frame through the video. I'm going to go back to the beginning. I'm going to start stepping. You notice when I clicked that first time, nothing happened. The time advanced, but the bowling ball didn't move. It's a little glitch in our system. The second time I click it, the ball appears to move. So I'm going to go back. I'm going to reset my stopwatch back to 0. I'm going to write down time 0. I'm going to write down distance, so maybe that's 125 or 126. I'm going to go with 125. Then that's my first data point. Time 0, distance 125, or position 125. Maybe we should call it position because, well, the distance will be getting less. I don't know. However you want to view that. Then we go 1, 2, 3, 4, 5 frames down. We're going to write down our new time, 0.0833, and our new distance. Maybe that's 120 or 121. I'm going to repeat that. 1, 2, 3, 4, 5. Time 1.1667. Distance 116. 1, 2, 3, 4, 5. Again, new time, new distance, 1, 2, 3, 4, 5, new time, new distance, 1, 2, 3, 4, 5, new time, new distance, and so on. Get at least 6 or 7 points of data for that. Then you're going to take your data, take it over to Desmos, make a graph. I think you guys are all familiar with that. If you're not, I've got some videos. It's the same procedure from the last lab, put in a data table, put the data in the data table, find an equation that fits your data. You can base your equation on y equals mx plus b. When you type that into Desmos, if you choose to do it that way, it'll generate some sliders. When you generate those sliders, you're probably going to have to make your m value be greater than or maybe less than the maximum or the minimum. So if you slide your slider over to one end and it doesn't go as far as you want it to, click on the number that's right next to where you slid it, and you'll be able to enter a bigger number. And then you should be able to slide your slider further until you can get it to fit. Or you can just put in numbers instead of M and B. You can just start throwing numbers in there and see what your graph does until you can make it fit. Or if you're clever, you can use that tilde function. There are separate videos for this whole process available to you. It's a little bit different, but I think you can figure it out. Once you've made your graph, you're going to come down to question 4. You're going to make a screenshot of your graph in Desmos like we've done before. Instead of putting it into a Google Doc lab report, we're going to insert it right here. Click on this little icon here. It's going to pull down a menu. You're going to find your screenshot. Here's all of my embarrassingly many screenshots. You're going to pick the correct screenshot. Choose open. This is not our correct screenshot, but you get the idea. I'm not going to insert it, but you can. Then you're going to look at that graph, maybe use your equation to try to figure out exactly when you think the ball is going to reach the flag. There's an exact time available in the graph. Think about what we're doing here. We're trying to see when the ball gets to position 0. So look at your graph, find position 0 on your graph, and you should be able to find a time associated with that. I'm not going to say more right now. I'll let you kind of try to figure that out. You should be able to say it within at least a tenth, if not 100th of a second. So 2.1 or 2.12 seconds will be the kind of answer I'm looking for here. I need you to do that. In order to get a good grade, you need to have a reasonable prediction right here. Then you can lock your answer once you think you got it. And move on to part 2, where you will test your prediction. So you think you've got an answer. You're going to choose the same trial in part 2, and you're going to be able to run all the way to the end. Look at that. It goes all the way to the end. You should be able to find the time in the video where the ball reaches the flag, like right in there. Note the time. You'll want to use the stopwatch, of course. Note the time. Record the actual time down here. Compare it to your prediction and tell me, like, how close were you? Were you real good? Were you kind of good? And then what does a negative slope tell you about the motion of this bowling ball? And try part 3. I'm not going to go any more into this. You can read it. You can do it. I believe in you. All right, this should get you introduced. Thanks for watching. Hope this wasn't too long. Good luck.